Hello, good morning everyone. Today we are going to see operating system session 16. In the previous topic, we have studied the topic operating system services. In the today's topic, we'll see one new topic, that is system calls. In the previous videos, we already discussed the overview about the system calls, and this is very important topic from the exam point of view. Surely there will be the questions based on these system calls. So listen this properly. So let us understand what are system calls. So in the previous topic, operating system services, we have seen this diagram. This is a user mode and this is a kernel mode, and in between we are having here system calls. So what is the work of system calls here? It acts like an intermediary between the user mode to kernel mode. So it passes the messages from user mode to kernel mode, as the user processes don't have the access to the kernel. So with help of the system call, all the user requests will be passed to the operating system's kernel, and with the help of the system calls, it will provide the operating system services to user. So we can say that system call is a program which requests a service from an operating system, that is from kernel. So system call provides services to the operating system. User process don't have access to operating system kernel mode. So through this system call, the user process interacts with kernel process. So let us see the definition. System call provides the services of the operating system to the user programs through application program interface. So system call fulfills the request of the user through this application program interface. So what are the application program interface? You can say it is a set of protocol or routines, that is units or functions that programmers use to develop software. So overall, the main work of these APIs is to facilitate interaction between distinct systems, that is from user mode to kernel mode. So with help of these APIs, the interaction takes between the user mode to kernel mode. Another definition, system call is the programmatic way in which a computer program requests a service from the kernel of the operating system it is executed on. So programming interface to the services provided by the operating system. So this system calls are written in which programming language? It can be either in a C or C++, and those are called as application programming interface. So there are some of the APIs softwares available like Win32 for Windows and POSIX API for POSIX based systems like Unix, Linux and Mac operating system. So these are a set of APIs which are there for specific operating systems. So let us understand system call with help of an example. Suppose the user wants to copy the file from one location to another location. That means one file you are reading and one file you are writing. So we can say this is a input file and this is output file where you are writing. So this file will be stored in the kernel operating systems. So the kernel has the access to this hard disk from where the kernel can retrieve that file for reading and writing. So the user process is requesting to the kernel to read and write the file from one location to another location. So which are the system calls will be invoked during this process is, let us see. First of all, acquire. So which file you want to read, that we call it as input file, and on the screen you are going to display that message and then you're going to accept the input, and then next you're going to identify which is the output file where you're going to write. Then again you display that message on the screen, then accept the file for writing where you're going to write that. Then first of all you need to open the input file name for reading purpose. If file does not exist, then the operation will be stopped there. Okay, one more, create output file. Now suppose if the output file is not there, then you are going to create the output file, and if file already exists, then again operation will be stopped. Okay, now if both input and output files are present, or if the destination file is not there, it will be created. Then read from input file and you are going to write to the output file. Then it goes on repeating until all the contents are read, or read until fails. Then close the output file where you have copied. Then write completion message on the screen and terminate normally. So these are the various system calls which will be taken between user process to kernel process. So let us understand an example of standard API. System calls take the help of the APIs. APIs are nothing but a function which is having a set of code which it will recognize and execute. So whenever a system call is called, then it recognizes the APIs. So APIs are in this form. So it will recognize the API, that is it will recognize function name and the various parameters, and it will execute a set of code, and according to that it will return the value to the user process, and like this way the various system calls will be executed with the help of these APIs. System call implementation. So number associated with each system call. So there is a number associated with each system call. There is a system call name as well as the number is associated, and it maintains a table index according to these numbers, and it is called system call interface. So the system call interface invokes the intended system call in the OS kernel and returns the value according to that. The caller need not know about the system call is implemented, so just needs to obey API and understand what operating system will do. So most details of operating system interface is hidden from programmer. So whenever a system call is called, so all the API execution, these all process will be hidden from the programmer, and just it will invoke the system call and it will return the value to the user process. Now see this another example. So now see this another example. Now suppose the user wants to open any file, and now it is going to call open system call. So when it comes to the kernel mode, from a table it is going to recognize which type of system call it is, and according to that it is going to execute, and then it is going to return the value to the user according to that. See another examples, standard C library example. So C program invoking printf library call which calls write system call. So in a program, when you write your program, you use printf to print something on the screen. So actually it is nothing but write system call. So from the user mode you are executing that, then that request will go to the kernel mode, then it will find out the API of write system call, and it will return the value to the program. It will print the value on the screen, and for that it will use is standard C library where this all system call is stored. That means for programming purpose there is also one standard C library for that particular programming languages which is available in the operating systems. So the various examples of system calls. So system calls are also different based on the which type of operating system it is. So if you take Windows operating system, so these are the various system calls, and if you take Unix or Linux operating system, there are different system calls. So for see these system calls are divided into various functions. That is, there is a process control function, file function, device manipulation, information communication. So based on these components of operating system, the system calls have been divided. Process control, it creates process, exit process, wait for signal, object. This belongs to Windows operating system calls. And for whereas in a Unix Linux, if you want to create the process, the system call which is used is fork to exit the process, the system call, and for waiting, wait system call. And for file manipulation in Windows, create file, read file, write file, and close handle. Whereas in Unix Linux operating system, open, read, write, and close. So like this way, the various operating system have different system calls. So once the operating system recognizes the system call, it executes the related APIs which is associated with that. So in today's topic, we have understood system calls. In the next topic, we'll see more on the system calls. Thank you.